Now, as a professional technician, I'm gonna look and see, is a belt on there? That's easy to check. It's okay. I'm gonna look through the grill area and see if I see any damage other than bugs and stuff like that that may have caused the condenser to start leaking. And if that's okay, now I'm gonna move over to the repair manual and follow the steps in the repair manual, and I'll show you right here. So let's look at the repair manual. Important. For the AC compressor operation, outside air temperature must be above 3 degrees Celsius and 38 degrees Fahrenheit. Extreme cold temperature, you don't want to run your compressor, so that's lifespan on the compressor. Okay, first step, we'll start our engine, of course. Place a blower motor switch to maximum speed position. Place the AC switch to on. Place the air temperature control switch in its coldest position, and we're going to go under on this model, but we're going to slide in under there and we'll get you a view of that. And then we can go from there and see, does the AC compressor cut off? And in this instant, it does not. So it says park it. We know it didn't cut on. And it says, does it work? No. Go to step 3. And it says park the vehicle in a shade, open the windows. If the AC system was operating, we know it wouldn't allow the AC. And then it wants us to hook up our pressure gauges and see what our pressures are. Now I'm going to show you a quick way to check it with no gauges, no scanners, anything like that. What you can do is you can take and jump your low pressure cycling switch. What it is it's a safety switch to prevent from damaging the system if it gets too low freon. What we're going to do is we're going to jump that switch. It's just a normally open switch unless the pressure is up above 15 psi to turn it on. Now the repair manual says if you're going to jump it, put a 3-amp fuse between it and show you exactly what happens when you jump it. Now listen for the change when I connect the two. It'll be a second. Hear it? Now, this line here, one with a red cap on it, is going to get hot and it's going to start cooling. You'll notice it cooling right off the bat. Now at this point, what we're going to do is we're going to want to see if there's a temperature change. Now our red cap is high pressure, anything before it's high pressure. So we'll feel and see if that line is starting to heat up. And then at the black cap, or after the black cap, it should be cooling down. If it is cooling down, then we know there's probably enough freon in there that should make that cycling switch work. So at this point, I would just go ahead and get another cycling switch, which there's a link down below to get the right cycling switch for this. Next step, 4. Now when we hooked up the gauges, if you look, they was at 0. So we had no freon. That tells us what's going on. All right, the freon, we don't have enough freon in there to activate the low pressure switch to enable the ECM, or the engine control module, to say it's okay to turn the compressor on. I've found on occasion them pressure switches to go bad, but they're not. I mean, it's far and few in between. So most likely it's usually low freon, and in this case I showed you it was low freon. Now by simply jumping this over, we're running our compressor. That gives us a complete circuit check. This goes to input to the ECM. The ECM says, okay, our low pressure cutoff switch is okay, so we're above our 15 psi. Now, if this starts to get hot, this starts to cool down, you're not too low of refrigerant in order to run the system. So it's a good shot that this is bad. And we can go through and check our circuits and see, but we already know that most likely this is bad. The good thing about this, but there's a Schrader valve inside here that we'll get a wrench, we can screw that off, we won't lose any freon or refrigerant. Screw the new one back in, plug it in. We just need to make sure it's a low pressure, not a high pressure cycling switch. Now remember, this switch does not tell the AC it's okay to run. It tells the ECM that it's okay for the AC to run the compressor. So In this case, if your compressor does not shut on, the next step we'll look at and check the rest of the circuit going to that AC cycling switch. If we'll take a look at our schematic, we'll see here our low pressure cycling switch. This is our schematics, and what comes up is the PCM sends a 12 volt into our switch. The switch is normally open. Once we meet our 15 psi or more requirement, it closes this, it goes to ground. So it takes that 12 volts. The powertrain control module is looking to see, is this 12 volts or system voltage, or is this near zero? And if it says yes, it's near zero, it tells the powertrain control module that it's okay to go ahead and turn the AC compressor on, because there's not an issue in this part. So when we jump this section out, what we're doing is taking this 12 volts to near zero through this ground. So once we jumped it out, it's pretty much told us this circuit is all good and this is good if your AC compressor cut on. So that eliminates all our other circuits and inputs and outputs that it needs to run that AC compressor. So we know we're good there. So what we basically done is checked this circuit out. Now if we still get no response, we can take a voltmeter right here. We can check resistance to ground. I'll show you how to do that. And if we've got a good resistance, then we'll take and check and see if it's dark green wire, if we have 12 volts or system voltage. Now you got to understand that 12 volts is whatever the system voltage. So if you've left your switch on and your battery is going down, that's going to be less than 12 volts. And if you've got the engine running, that's going to be system voltage, whatever, with the alternator, so it could be up to 14 volts. But we're looking for system voltage. I'll show you how to quick check that. Now, since how we know that's what we're looking for, we're just going to take our meter, and first we're going to set it on resistance scale, the lowest resistance scale. Then we're going to come over. Now, if you looked at our schematics, it says that it should be ground all the time. So it's not being turned on by anything. It's continuously being grounded. Wire color is black, so we can find us a good ground. Check our meter. We want to check our meter and make sure that the meter, the leads, wires, everything has resistance in it. So we're checking to see what the least amount of resistance, 0.2, and get on our black wire and get on a good ground. Now we're coming off negative side of the battery. Now this also is going to tell us how good our engine ground is. So now we're going to hook this. All right, we're going to go through the black side of our pigtail, and let's see if we get a good ground. 0.6, 0.5. Now I'm going to stop it right here. Here is one thing you've got to remember, that the engine has to be off. There's got to be no loads on the circuit when you're checking the resistance. Because the more loads, the higher resistance, and it'll give you a false reading and make you think you've got a weak ground when actually you don't, because the higher the loads, the higher resistance reading you'll get. All right, now we do know that we had 0.2 to begin with, so actually we got 0.3 ohms resistance. Very good. So we know now our ground is good. Now this system always works. This voltage, when I turn the switch on, the engine doesn't have to be running. So let's take a look at that. Now we're going to check. We want to know what system voltage is. With the switch on, and if you'll notice, like any other GM product, we have got our headlights is on as well. So let's take a look and see what actual voltage is. We're going to move this back to a 20 volt scale. All right. So with just the switch on, if you look, we've got 11.73 because our running lights is on. That's pulling the battery voltage down. But our system voltage is 11.73. Now we're going to go on what is our schematic says. It should be a dark green wire on our pigtail. Now then, if we're doing things right, we should have, now this has got to be disconnected. Our system voltage. System voltage 10 volts, so we're still good there. Now if you if you've got enough Freon in here and this switch is working right, watch this. Like I said, it says it'll take it to near zero. We've got 10 volts. Let's see what happens when we should have, this should go down to near zero. Look at there. Unplugged. So it's doing its job. And for another quick test, if you wanted to, you could just set this on a 20 volt scale, check and see what our voltage is, and just check this wire here. It should be zero. Then all you have to do, because what you want to do is make sure it's getting a 12 volt signal from the ECM. Unplug your, getting close to system voltage. So it tells us, really if you look at it, it tells us that the entire circuit is good here, including our switch. So you can just come through, check this. If it goes to zero, this circuit is good. And when I say this circuit is good, we know just off of the schematics, what does it tell us? Low pressure cycling switch should receive a ground. If the switch is closed, it should take this 12 volts down to zero. Then we know this part of our circuit, just by going through and checking that, we know this part of our circuit is good. It says there's enough Freon. It says low pressure cycling switch is working. It says ECM sending the 12 volts and it's taking it to ground. So that tells us this whole portion, this portion here is good. And if you look, ground 102 also grounds the low pressure cycling switch and the clutch. So, and it's spliced right here. So at least to here it's good. If our compressor didn't run, most likely our compressor ground is good too, because they're both grounded in the same spot. They usually don't have a problem in the splice. They usually have a problem where they're actually bolted on. So we have eliminated that. Just on that little quick check, we know that we're supposed to get system voltage. We did. We know that if this part of the circuit's working and there's enough Freon, it should take it to zero. So that pretty much told us real quick that we've took it to zero. Low pressure cycling switch is good and the circuit is good. That didn't mean our compressor is going to run, but when you jumped it out, like I showed you, and the compressor run, that tells the rest of the circuit's good. So the only problem we have is there enough Freon to turn this down, turn this on? And if there is, then this is our problem. Now sometimes as a technician, we forget, especially if you've been in it for years, you forget what younger technicians or people who's not experienced with electrical may not know. So I hope in this video I explained it. If I didn't, you can leave a comment and I'll try to clarify it a little better. But I hope you got some value and then don't feel like you've wasted your time. And in the next video, we'll check another portion of the AC circuit. But this one's running long, and I know this will get you started. We got our feet wet on electrical, so maybe we can get more value out of the next video and you can learn and be a little more educated, even if you're a consumer and you want to know what's going on and if you've got an actual technician working on your car. Thank you again.